Hello everyone, welcome back again. This is Mathematics and Physical Sciences Simplified. Today we are going to be looking at work, energy and power. Before we can start with our topic for today, don't forget to subscribe to our channel, like our video and share to your friends, and click notification button so that when we upload another video you'll be able to get the message and you access it. Thank you. So let us start. Work, energy and power. In this lesson we'll be focusing on work. See, remember from the lower grades, what is work? What is work? All right, before we can go to work, and you know that work, if a person can do work, that means that person is having energy. There is no one who can do work without energy. So let's start by defining what is an energy. What do we call? What is an energy? In grade 1 or grade 2, you learned about energy. Energy is ability. You see, energy is ability to do work. This is energy. Energy is ability to do work. Now, what is this work that we are talking about? Don't forget that the definition, work done on the object. The work done on the object is equal to the product. Is equal to the product of force and displacement. You see, is the product is equal to the product of force and displacement. That force acting on the object. Remember, displacement, we are also going to talk about direction, because displacement is our what? Displacement is a vector. You see, vector quantity, so it have direction. So meaning that don't forget, friends, work done is measured in what? In joule. Is measured in joule. This is G. The work done on the object is measured in joule. And then what we need to know, don't forget that the work done is a what? It's a scalar quantity. You see, it's a scalar quantity. It does not have direction. You see, so it's a scalar quantity. Now, the work done on the object by the net force is shown by, this is how we show it. We say W net. You see, W net is equal to F net change in X. So this is the formula that we use when we want to calculate the net work done on the object. But work done by a constant force, you must know that it's W is equal to F change in X cos theta. So this formula, we use it when we want to calculate the work done by a constant force. We can use it when we want to calculate the work done by a frictional force, when we want to calculate the work done by what? Applied force, work done by tension, or any other force that we have. So this, what about this theta? What about that theta? What is that? Remember, I said work done on the object is equal to the product of force and displacement. So that displacement, this theta is talking about direction. You see, direction of the motion. This is the angle between theta. Let me take it up there so that you can be able to understand properly, so that you can be able to see it. Remember, this is it's a homeschooling, so don't be surprised when we see our board moving. Now let's proceed. We are having W is equal to F changing X cos theta. So this is the formula we use when we want to calculate the work done by a certain force, a constant force. Theta, what is this theta? Is the angle between, this is the angle between, is the angle between the force and displacement. Or you talk about motion of the what? Of the object, the direction of the motion. You see, I can put direction here, direction of the motion of the object. So that's what we call theta. You see, so that's you'll be able to understand. Recall trigonometric, because this theta is about trig. This is a trig ratio, by the way, as you can see. Now, if you see that we are fast, you can pause the video so that you copy the notes, then we proceed. And then the next thing that we're going to be looking at, let me say recall. Let's recall cast rule. Let's recall the cast rule from mathematics. This is 0, this is 90 degrees, this is 180 degrees, and this is 270. As you can see, let's say your object is here. This is the object we are having. This is our block. We want to calculate the work done by a constant what? Force. So meaning that if this object is going to the right, if this object is going to the right and the force applied is going to the right, it means that theta will be what? Will be 0. You see? So because the force applied is applied in the direction of the motion of that object. Even on this one, if ever the object is here, is moving to the right, and then a force is applied going upward. Can you see a force applied going upward, but the object is going to the right? It means that the angle between a force and the motion is 90 degrees. Meaning that here you're going to say W is equal to F change in X cos 90 degrees, because the force applied is perpendicular to the motion of the object. You see, for which that work done, it will be 0 joule. Work done by the force acting perpendicular to the motion of the object, that means it does not do any work. You see, so even let's say for example a person is going to fetch wood in the bush there. If they go there and they get some wood, the work they do is to put on the head. When they come from there coming back home, there is no work that they are doing. So they must not say they are tired when they come back, because there is no work that they are doing. Now let's proceed. Here, let's check about the work by 180. If the object is going forward, you see, to the right, and then a force is applied opposite to the motion, that means it's W is equal to F changing X cos 180 degrees. Meaning that the answer here, it will be negative. The work done, it will be negative. Every time the work done by the force which is opposing the motion, you use 180, because cos 180 is negative. You see, it's negative 1. Now let's check the work done by the force which is going down. Work done by gravity. You see, what about work done by gravity? So you'll say W is equal to F changing X cos 270 degrees. When you press a calculator, you will get what? 0, because cos 270 is 0. So meaning that when you are working, when you are working, the forces which does work is a what? Is the force which is acting to the direction of the motion. The force which does negative work is the force which opposes the direction of the motion. Forces which does 0 work, those are the forces which are acting perpendicular to the motion of the object. The force which is going up 90, force which is going down 270, this one they do 0 work. This one it does negative work. This one it does what? Positive work. I hope we are all together here. Now, let's go to example. Let's see if we can be able to calculate the work done. Like I said, we're going to be talking about work done on the object on this video. Now let's have an example. Let me just draw a diagram here so that it can be easy for you to understand. This is our 5 kg block. There is an applied force to the right. We say 200 Newton. And then we also have a frictional force of maybe 10 Newton. So the change in X here in this thing is 10 meters. So as you can see, you see, look at this object here. This is like an example. That's why I don't have any information. I'm just writing an example. Now, this object is going to the right. Now, my first example, I will say, calculate the net work done on the object. That's the first thing. Calculate the net work done on the object as it moves to the right. As you can see, this object is going to the right. Calculate the net work done on this object. What do? You're going to calculate the work done by each forces, or you do the F net. This is option 1, you see. Option 1, you will say work done by applied force. What is the work done by applied force? Applied force, change in X, cos theta. What is the applied force that we have there? It's 200, see? Then change in X is 10. Here we have cos. Look, this motion is going to the right, and this force is going to the right. So meaning that this one will be cos 0, because it's going to the direction of the motion. When you reach here, when you multiply here, this one will give you 2000 joule. This is the work done by the applied force. Now, I'm going to the work done by frictional force. Frictional force, change in X, cos theta. What is the frictional force? 10. Change in X, 10. Cos, what about friction? Cos, that means it will be cos 180. Why 180? It's opposing the direction of the motion. So the answer 10 times 10, negative 100 what? Joule. So what is the net work? What is the net work done on the object? You are going to add this thing. 2000 plus negative 100. Then you press a calculator, you will have 1900 what? Joule. This is the net work done on the object. See? The net work done on the object. Now, as you can see, what we are having is option 1. Now, we are going to erase as we go to option 2 so that you can be able to understand what's taking place. I will do the last question, then we are done. Okay. Now, option 2. Let's look at it. Option number 2. What do we have? Someone can say, I love Newton. Someone can talk about F net. F net is equal to the force which are going to the direction of the motion are positive. F applied plus into negative frictional force, you see, which give you 200 minus 10, which is 190 Newton. This is the F net, you see. And then someone can come and then you write work net is equal to F net change in X. What is the F net there? It's 190. Change in X, it's 10. So what is the work net on the object? 1900 what? Joule. You see? Two options, they give you the same answer. That means this is how you calculate the net work done on the object as it moves along the horizontal surface. Now, let's take this object and we take it up on the incline. Let's take it on the incline. So as we are moving together, you can see that there's some shadow here. As I said, it's a homeschooling. Let's proceed. Now, we are going to get an example. Example number 2. Let's say we are having an incline. You see? We're having an angle here, 30 degrees. We are working with our box here. This is our 5 kg block. and then the displacement. See, we are still talking about 10 meters from down here up there, and then we have our applied force. It is still 200 newton, and then our kinetic friction, we are still talking about 10. Now, as you can see, I want to say calculate the net work done on the what? On the object as it moves up the incline. See, let's assume, remember learners, this is just an example. That's why we don't have any information about the type of the block, what's happening, angle, what. You can see we have an angle there. So this is just an example. Calculate the net work done on the object as it moves up the incline. How do you find the net work done there? You are going to remember there are forces which are acting relative to the motion of the object. Now we're going to get the work done. Remember, we will stick with our option 1. Okay? Now, the work done by applied force, remember, I hope you still remember from the previous example. Applied force, change in x, cos theta. We got our 200. Change in x is 10. Cos 0, because it's going up there. You see? Don't be tempted and use this. Here, theta is the direction of the motion. Is the angle between the motion, displacement, and the force. So this is 2000 joule. This is the answer for this one. Now we go to the work done by frictional force. You see, work done by frictional force, it will be kinetic friction, change in x, cos theta. What do we have here? 10. Change in x, 10. Cos 30. No. It's not cos 30. Is 180, because the frictional force is opposing the motion. This thing is going up, the friction is going down. So meaning that the answer here to be negative 100 joule, the same as that one. But friends, now there is a force which was added there. If ever you see an object moving on the incline and you're having an angle, as long as it moves on the incline, we are going to talk about FG parallel. So meaning that you're going to say the work done by FG parallel is equal to what? Is equal to FG parallel change in x cos theta. FG parallel is m, 5 times 9,8. This is 10, and then we talk about cos. Remember FG parallel, it have a sine, so sine 30 degrees. Cos, remember the object is going up, and then FG parallel is going down, so it must be cos 180, you see. And then here we want to try to multiply this thing, and then as you can try to multiply, here you're going to get 50, here you're going to get 25, 250 divided by 2, and then somewhere there, negative 124,3 joule. So you can do that, and then you can calculate. That's what you will get if you press your calculator. Now, what is the net work? The net work done on the object. So here you can verify. I mean, I'm not sure, but if you press your calculator, you will get this one. You will get the answer for this one. Now, work net, what do we have? So you'll have 2000 plus into negative 100 plus into negative 124,3. You see? So meaning that, what are you going to have here? If you press your calculator at once, you're going to remove 2, it will be 1.8, and then now it's going to be 1.7 5,7, you see, joule. If you press your calculator, you might find that we are not pressing right, but if you press a calculator, you're going to be getting the correct answers. But this is the net work done on the object. You see how easy it is. You do the work done by applied force, work done by friction, work done by FG parallel. After you add everything, Therefore, when you add everything, it will give you the net work done on the object. Now, let's go to the last example. The last example, remember this block, we started with it on the horizontal surface. We take it up on the incline. Now, let's take it from up there when it is going down. See? Remember to pause the video. If you see that we are fast, you can pause the video and then you copy. And then some of the questions you can try to answer them before you play the video. Now, let me have the same incline here. But I just want to change this question so that you can be able to understand. This object, it's up there. We are talking about our 5 kg. You see? This time around, let's just change here. We talk about our displacement from up there is 15 meters. You see? And then this object, it was released from rest. You see? It was released from what? Rest. What does it do? It is sliding down. And it is what? Sliding downwards. On the what? On the incline. This is what is taking place. So the direction of this motion is downwards. You see? Our kinetic friction, you remember it's here, is still the same. 10 Newton. Don't forget. It's 10 Newton. But this time around, what is happening is that this object is on the incline. Now it's coming downwards. From up there, calculate. This is the last question. Calculate the net work done on the incline. Net work done on the object. While sliding downwards. Look, this is the question. The net work done. Before you check, do we have applied force there? No. What are the forces that we're having? Friction and FG parallel. So meaning that you're going to start by saying work done by the frictional force we have there. It's frictional force, kinetic friction, change in x cos theta. I think we calculated it there. We have a 10. Our change in x now is 15. This is cos what? Friction every time, class. It's cos 180 because it opposes the motion. The answer will be negative 150 what? Joule. You see? That's the work done by the kinetic friction. So what is the other force we are having? It's on the incline. We must have what? FG parallel. So work done by FG parallel is equal to mg sine theta change in x cos theta. What is the mass? 5. 9,8 sine 30 degrees. Okay. 15 cos. It will be cos what? This object is moving downwards and FG parallel moving downwards. That means it must be cos 0. See? And then with this information that we are having, we're able to see that sine 30 it's a half. You see? So it's 1 over 2. So 15 divided by 1 over 2, it gives us 7,5. You see? And then when you 7,5, 15, you see? So that means here, this one is going to give you 67,5 multiplied by 9,8. So meaning that this one is going to give us 668,3 joule. So this is what we're going to have. But since we are not, I forgot my calculator. But you can just use your calculator there where you are at, and then you press the work done by FG parallel. You can take a calculator there and press, and then after you go and calculate the net work. What do you do? So between these two, which one is going to be positive? That means it's this one. So you're going to take the answer you get here. You write it here. Then you say plus into negative 150 what? Joule. Then at the end, the answer that you will get, we call it the net work done on the object while it is sliding down. So on this video, we were focusing on how to calculate the work done on the object, the net work done. I told you about the negative work, the positive, and also the issue of the zero work. So on the next video, we are going to be focusing on work energy theorem and work done by non-conservative forces, the principle of conservation of mechanical energy. So thank you so much. Don't forget to subscribe to our video. Until we meet next time.